Okay, let's start with a new chapter today, progression. So progression is divided into two parts. That is, first is arithmetic progression, the other one is geometric. So we do today only on this first part, arithmetic progression. So what is arithmetic progression? Is a sequence of numbers that is obtained by adding a constant to the term before it. Okay, you can find this definition here on page 129 of your textbook. Okay, on the top there. So, for example, if I was to start a number with number 3, then maybe I add 4, then it becomes 7, then it becomes 11, then it becomes 15, 19, 23, 27, 31, and so on. So this one is T1, the first term. T2, T3, T4, T5, T6, T7, T8, and so on and so forth. So what are not arithmetic progression? For example, if I start with 5, 9, 13, 16, 20, so this one is not an arithmetic progression. Why? Because look at the top first. 7 minus 3 will be 4. 11 minus 7 will be 4. 15 minus 11 will be 4. 19 minus 15 will be 4. 4, 4, and 4. But this one, 9 minus 5 will be 4. 13 minus 9 will be 4. 16 minus 13 will be 3. 20 minus 16 will be 4. Only one of them will not be 4, but still it is not a arithmetic progression. Okay, let's continue with Self Practice 5.1. Self Practice 5.1. Find the common difference for each of the following arithmetic progression and state the method to obtain the arithmetic progression. So, number 1A, starting with negative 35, negative 21, negative 7. So, is it yes or no? So, the answer will be yes. Why? Because if you subtract negative 21 minus negative 35, you will get 14 when negative 7 minus negative 21, you still get 14, and state the method. Okay, so what you have to do in order to find the next term, add 14 to the next term. So the next term will be negative 7 plus 14, which is 7, and then so on and so forth. B, 2 square root of 3, and then 5 square root of 3, and then 8 square root of 3. So, oh, there is no yes or no here, just that how to find it. So, this is the common difference will be 5 square root of 3 minus 2 square root of 3. Okay, we don't have to test twice because it is an arithmetic progression. They don't ask you for whether it is a progressive arithmetic progression or not. So you find the difference will be 3 square root of 3. So the next one will be 11 square root of 3. Because 8 square root of 3 plus 3 square root of 3 will be 11 square root of 3. And C, P plus Q and 2P and 3P minus Q. The difference will be 2P minus P plus Q. It will be 2P minus P minus Q. So it will be P minus Q. So in order to know what is the next one, will be this plus this. That is 3P minus Q plus P minus Q. So it will be 4P minus 2Q. In case you need to know what is the next term, you just add. Okay. And D, log A2 log A2 power 4, and then log A2 power 7. So I will simplify this. Log A2, the next is 4 log A2, 7 log A2. Okay, even though we do not know the value, but still we can subtract this minus this. 4 log A2 minus 1 log A2 will be, the difference will be 3 log A2. In case you need to know what is the next term, will be 10 log A2. Okay, so in case that they want you to give in like this, so the answer will be log A2 power of 10. Okay, let's continue with number 2. Determine whether each of the following sequence is an arithmetic progression and give your justification. So number 2, 8, 9, 13, 17 and 21. Is it arithmetic progression? You find whether there is a common difference. 13 minus 9, 17 minus 13, 21 minus 17. So all you get 4. So it is. So yes. Okay, why? Because common difference equals to 4. How about B? 1 over 2, 1 over 4, and 1 over 6, and 1 over 8. Yes or no? No. Because 1 over 4 minus 1 over 2 will be negative 1 over 4. 1 over 6 minus 1 over 4 will be negative 1 over 12. Okay? So because this one is not an arithmetic progression because there is no common difference. Okay, then D, C, 0.1, C, 0.1, 0.01, and 0.001. So the answer would be no, because this minus this will be 0.01, 0.01 minus 0.1 will be negative, the difference here, negative 0.09. And then 0.001 minus 0.01 will be, here the difference will be negative 9 times 10 power negative 3. Okay, so it is negative 0.009. And how about D? We have here is 5 minus x, 5 minus x, 5 and 5 plus x. This one I do not know. Let's test. 5 minus bracket 5 minus x will be 5 minus 5 plus x will be x. And this one minus this one, 5 plus x minus 5 will be x. Okay, so it is, yes, it is an arithmetic progression because they have a common difference of x. Okay, number 3. Complete the network diagram below given that the relationship of each of the following network is a consecutive term in an arithmetic progression. So 8, 10 will be 9. Okay, plus 1, plus 1. But then here will be plus 4 will be 13. And then here, I do not know if you have two parts or two circles that you do not know, you cannot solve it. Okay, so what is important is that in the middle here is the center, or in the middle is the middle of these two values. Okay, so this one and this one will be in the middle. So in order to know the middle, just add this and divide by 2. So 2p plus 12p, 14p, divide by 2, you get 7p. Okay, then so 2p plus 5p plus 5p will be 7p. 7p plus 5p will be 12p. And then here we have 2, negative 1 plus 7, you get 6. 6 divided by 2, you get 3. So 3p. So 3p, 2p, 1p. Here 7x, 12x. What is here? So I need to calculate. So if I just put this as p here, I say 7x plus p over 2 equals 12x. So 7x plus p equals 24x, 12 times 2. And then p will be 24 minus 7 will be 17. 17x. 17x. Okay? 7x plus 5x, 12x, 12x plus 5x will be 17. Now we can solve this one. Okay, the network is not completed yet. 17 and 5 now. Okay, 5 plus 17, you get 22. 22 divided by 2, you get 11x. And then here is the middle between these two values. 7 plus 11 will be 18. 18 divided by 2, you get 9x. So 9x is also in the middle between 17 and something here. What? P plus 17 over 2 equals to 9x. So you get 18x here. So 18 P plus 17x. So P will be 18 1x. Okay, so P will be 1x. So x. So this x plus 8x, you get 9x. 9x plus 8x, you get 17x. Okay, we completed our network. Okay, number 4. Azrul and Jonathan are placing national flags along the school corridor from the canteen to the staff room. The distance between the first and the second flag is 5 meters. The third flag is placed 10 meters from the first flag, and this is the pattern of arrangement for the rest of the flag until the end. Determine whether the arrangement of the flag follow arithmetic progression. Give justification for your answer. Okay, so this is the first one. Okay, so after 5 meter will be the second one, and then here will be after 10 meter. Okay, this is 10, this is 5. Okay, so is it follow certain arithmetic progression? Okay, so because this is 10, so this is another of 5. Okay, so the answer is yes. Okay, so because the first one after 5 meter, second one after 5 meter will be the third one, and so on and so forth until the end of the corridor. Okay, so because the difference is 5 meter from one flag to another. That's the justification.